Hey guys, Sturzel over here, and today I'm going to be giving a science presentation about heat and temperature. So, let's get started. So, the most recent question is heat and temperature the same thing? No. We all notice that when you heat something up, the temperature rises. Often we think that heat and temperature are the same thing. However, this is not the case. Heat and temperature are related to each other, but have different concepts. So, heat is the total energy of molecular structure or motion in a substance, while the temperature is the measure of the average energy in a molecular motion in a substance. Heat energy depends on the speed of the particles and the number of particles, or the mass. Temperature does not depend on the mass, only on the speed. For example, the temperature in a small cup of water might be the same temperature as a large tub of water, but the tub of water has more heat because it has more water, thus more total thermal energy. So now we have the degree of hotness and the quantity of hotness. The degree of hotness is the speed of the molecules, but the quantity of hotness is the speed and the mass. The other name for a degree of hotness is temperature, and the other name for a quantity of hotness is heat, thus proving that heat and temperature are different things. So, next, here we go. So next we have expansion and contraction. So, as materials warm up, the particle model of matter, we'll get into that later, says that their particles move faster and spread apart. We expect substances to expand or increase in their volume as the temperature rises. Falling temperature means that the average particle motion is slowing down, and it seems logical to expect substances to contract or decrease in volume as they cool. So yeah, an example of that could be concrete. Whether it's a bridge, a highway, a building, the concrete is not immune to the effects of temperature. It expands and contracts with changes in temperature occur regardless of what it is, whether it's concrete structures or wood. It always does. So yeah, next that question. So, this is a big one. So, to answer what I said earlier, what is the particle model of matter? Well, the particle model of matter is a theory that explains the properties of solid, liquid, and gas. So, I named these myself. They're terrible, so I'm sorry. So, and I know it's backwards. Sorry. So, yeah. As you can see, solids, their molecules are really, really tight. Like, they're close together. They can't move around freely. And solids are always in a fixed shape. But they can't move around freely, they do vibrate a lot. They do vibrate at the same time. And they have a fixed shape. I'm not sure if I said that. So, then we have liquids. So, liquids move around a lot. Again, backwards. Like, they move around quite a bit. Like, they have about the same amount of space as a solid in between. They have a little more space, so they can slip past each other, move around, vibrate, rotate, do all that kind of stuff. So, yeah. And they take the shape of whatever container they're in. For example, I have some Mountain Dew, and it's taking the shape of its container perfectly. So then we have gases. Gases have a large amount of space in between, like a large amount of space, and they can move around wherever they want. They're like running past each other, basically. They're moving so fast. And yeah, in gases, they don't take the shape of a container, but they do fill the entire container. You can't see it most of the time, but they fill the entire container. So yeah, there's that. Now, we have some key terms here. So it's basically me saying the definition of some things. So, first question is, what is absolute zero? Well, absolute zero is the point where no more heat can be removed from a system. according to the absolute or thermodynamic temperature scale. This corresponds to 0 K or minus 273.15 degrees Celsius. In classical kinetic theory, there should be no movement of individual molecules at absolute zero, but experimental evidence shows that this isn't the case. So yeah. Next question is body temperature. So, body temperature is a measure of the body's ability to generate and get rid of heat. The body is very good at keeping its temperature within a narrow, safe range in spite of large variations with the temperature outside the body. And your body temperature should be at 37 degrees Celsius. If it's any lower or higher, you're starting to get sick. Fever, cold, flu. Anyways, what is the boiling point of water? This one's easy and short. The boiling point of water is 100 degrees Celsius or 212 degrees Fahrenheit, sorry. And the atmosphere of pressure, like it has to be at 1 atmosphere of pressure for it to boil at that temperature. So, in other words, sea level. So, here we go. The freezing point describes the liquid to solid transition. Well, melting point is the temperature at which water goes from a solid or ice to liquid water. In theory, the two temperatures should be the same, but liquids can be supercooled beyond the freezing point of water is 0 degrees Celsius or 32 degrees Fahrenheit. The temperature may be lower if supercooling occurs or if there are impurities present in the water which could potentially cause freezing point depression to occur. So, we have one more question. What is a comfortable room temperature? A comfortable room temperature depends on your individual needs or other factors. For example, like the average room temperature is 22 or 21 degrees Celsius or 70 degrees Fahrenheit, according to the West Midlands Public Health Observatory in the UK. So yeah, 21 and 22 degrees Celsius or 70 degrees Fahrenheit is the recommended living room temperature, and 18 degrees Celsius is 60 or 64.4 degrees Fahrenheit is a good bedroom temperature. However, this may not be true for countries found near the equator. As the temperature is higher, the room temperature is around 30 degrees Celsius or 86 degrees Fahrenheit. So yeah, room temperature is a matter of opinion, really. Like, it depends on what you're comfortable with, but 22 and 21 are the average that it should be at for your living rooms and stuff. So yeah, but room temperature is really just what you're comfortable with and what you think is normal. So yeah, do we have any more questions? No? No more? Okay, so that was my presentation for Science 7 unit, and yeah, I'm Star Silver. I'm signing out. Shine on and keep the stars alive. See you later.